You know that feeling, right? You get to the checkout counter, you see the total on the screen, and you just kind of die a little inside. We've all been there. Food prices are just nuts. But what if I told you a big part of the reason isn't just inflation, but a hidden choice we're all making between the food we eat and the fuel we put in our cars? Today, we're going to be economic detectives. We're going to crack this case. Let's get into it.
Yeah, this is the big question on everyone's mind, isn't it? Why is everything so expensive? It feels like every trip to the supermarket is a wild ride. But the answer might not be where you expect. What if a huge piece of the puzzle isn't in the grocery aisle at all, but at the gas station?
Yep, you heard that right, your gas tank. See, policies promoting biofuels, especially ethanol here in the US, mean that a massive amount of our crops, we're talking corn, isn't being grown for food anymore. It's being turned into fuel. And that sets up this giant tug-of-war for the exact same resources.
And this right here is what economists call the economic problem in a nutshell. We have a limited amount of land, a limited number of farmers, limited technology, and we have competing desires. We want affordable food to eat, but we also want fuel for our cars. We can't have an infinite amount of both. So we're forced to make a choice, a trade-off. The real question is, how do we actually see what that choice cost us? Well, to do that, we're going to break out a really cool tool from the Economist's Toolkit. It's called the Production Possibilities Frontier, or PPF for short. Think of it like a map that shows us the absolute limits of what our economy can produce and the tough choices we have to face. So, what is this thing? Well, you can think of the PPF as the edge of the possible. Imagine our entire economy only makes two things, say food and fuel. The PPF shows you every single possible combination of those two things we could make if we're firing on all cylinders, using every worker and every machine perfectly. Everything on that line we can do. Anything outside it, well, that's what we wish we could do, for now.
Okay, let's make this super simple. Pizza and cola. Everybody loves pizza and cola, right? This table shows the choices our little model economy can make. At possibility A, we are the kings of cola. We make 15 million cans. But, sorry, no pizza for anyone. At the other extreme, possibility F, it's a pizza palooza, 5 million of them. But we're all thirsty because there's zero cola. And everything in between? That's just a different trade-off.
Now, when we plot those points on a graph, we get this curve. And this curve is everything. See, any combination of stuff on the line or even inside of it, that's attainable. We can do that. But a point way out here, outside the curve, nope, not going to happen. That's what we'd love to have, but our resources and our tech just won't let us get there yet. It's a perfect picture of scarcity. So, you want to be on the line. Being on the line means your economy is efficient. You're squeezing every last drop of potential out of what you've got. But what if you're producing at a point inside the curve? Well, that's a problem. That means we're being inefficient. Something's being wasted. Maybe factories are sitting empty. Or worse, we've got our best pizza chefs trying to figure out the secret formula for cola. It's a total misallocation. We could and should be making more of everything. And this idea of giving something up brings us to maybe the biggest, most important concept in all of economics. The idea that there's no such thing as a free lunch. Every single choice has a cost. And I'm not just talking about dollars and cents. I'm talking about the cost of the road not taken. We call this opportunity cost. The textbook definition is right there, but let's just break it down. Opportunity cost is simply the value of the very best thing you didn't do. So when our economy decides, hey, let's make more pizza, it has to give up making some cola. That cola we could have had, that is the opportunity cost of the pizza. So let's actually calculate it. What's the real cost of getting 1 more million pizzas? Let's say we move from point C to point D. Okay, what do we gain? We get 1 million more pizzas. Awesome. But what do we lose? We have to give up 3 million cans of cola to make that happen. So there it is. The opportunity cost of those million pizzas is 3 million cans of cola. Now, you might have noticed something about the shape of that curve. It's not a straight line, is it? It's bowed outwards. And that's not just for looks. That curve's shape is telling us something incredibly important. Opportunity costs are not constant. In fact, the more of something you try to make, the more expensive it gets in terms of what you have to give up. So why does it do that? Well, think about it. Not all resources are created equal, right? To get our first million pizzas, we probably just move some chefs who are already good with dough. It's an easy switch. We barely lose any cola production. But what about when we want that 5th and final million pizzas?
Now we have to grab the world's best cola scientists and tell them, hey, start tossing dough. It's a disaster. We end up sacrificing a mountain of cola just for a few more pizzas. That, my friends, is increasing opportunity cost.
Okay, so this PPF sounds a little depressing, right? Like we're trapped inside this box of choices forever. Well, good news, we're not. There are two powerful ways we can break out and expand our possibilities. The first is economic growth, and the second is trade. Let's dig in.
First up, economic growth. This is when the entire frontier pushes outward. How does that happen? Two main ways. First, new technology. We invent a robot that makes pizza 100 times faster. Second is what economists call capital accumulation, which is just a fancy way of saying we get more tools and skills, more pizza ovens, more factories. Of course, there's a cost here too. To build more pizza ovens today, we have to stop making pizzas today. So we sacrifice a little now for the benefit of having way more of everything later. The other way to get more stuff is through trade. And the engine that drives trade is this really beautiful idea called comparative advantage. Now, this is key. Comparative advantage is not about who's the best at something overall. It's about who can produce something at the lowest opportunity cost. It's about who gives up the least to make it.
Let's make this real. Meet Liz and Joe. For Liz to make one smoothie, she has to give up making one salad. Her opportunity cost is 1 for 1. Simple. Now look at Joe. For him to make just one smoothie, he has to give up making 5 salads. Whoa! His opportunity cost for smoothies is huge. But let's flip it. To make one salad, Liz gives up a whole smoothie. But Joe, he only gives up a tiny fifth of a smoothie. See the difference?
And that is the whole game right there. Because Liz has the lower opportunity cost for making smoothies, that's her comparative advantage. And Joe, even if he's slower overall, gives up way, way less to make a salad. So that's his comparative advantage. I'll say it again because it's so important. It's not about being the fastest. It's about who gives up the least. Okay, now for the magic. What happens if Liz only makes smoothies and Joe only makes salads, and then they trade? Well, look at the numbers. It's amazing. After they trade, they both end up with more smoothies and more salads than they could have possibly made working by themselves. It's like they've created wealth out of thin air, just by specializing.
And that is the mind-blowing power of trade. By focusing on what you do most efficiently, everyone can consume at a level that was literally impossible for them to achieve alone. They are living outside their own personal PPF. It is a true win-win. All right, we have our tools, we understand the production possibilities frontier, we get opportunity cost, and we've seen the magic of trade. Now, let's put our detective hats back on and return to the original crime scene, that grocery store checkout.
So, piece number 1 of the puzzle. When the U.S. decided to produce more biofuel, farmers moved resources, land, tractors, fertilizer, over to corn for ethanol. In our model, this is a movement along the country's PPF. And as we now know, when you move along that curve to produce more of one thing, you get to the steep part where opportunity cost skyrockets. The cost of using corn for food got really, really high. And that cost, it gets passed on to you. But that was only half the story. At the exact same time, major droughts were hitting other food-producing parts of the world. Now, for them, it wasn't a choice. Their entire PPF literally shrank inwards. A natural disaster meant their maximum possible output just collapsed. So you have this perfect storm. The U.S. is choosing to turn food into fuel, while other countries physically can't produce enough food. The global supply gets squeezed from both sides, and boom, prices go up for everyone. And there you have it. The case is solved. The high food prices weren't just a random event. They were the clear result of a massive trade-off, food versus fuel, made way worse by a global crisis. Economics gives us these amazing tools to see the hidden costs and measure the trade-offs, but it can't answer the ultimate question for us. Now that we know how to see the choices, who gets to decide which ones are worth making? That's a question that goes beyond the graphs to the very heart of what we value as a society.